Entropy. Today I recalled that once I was thinking about this concept for a long time. If to say briefly, entropy is a measure of disorder. It would seem that we have defined some unknown concept using quite a household word, disorder. A measure is a degree or level of something. Let's clarify what a disorder is. And on this way we will find out what order is. Mothers usually scold their children that they have messed up in their room, and force them to make order. In this case, if one asks a mother whether she can clarify what is a mess, it can be assumed that the average mother would say that things are scattered around the floor, or they are not in their right place, or that rubbish is lying all over the floor. In this case, the order making would consist in moving things to their places, and in sweeping the floor. And now let's take a look at the room cleaning in terms of physics. If we have a number of things arbitrarily scattered across the floor, which occupy the biggest possible surface, then we can say that this state is described by some number. You can even calculate the exact amount of entropy that characterizes the objects scattered on the floor. But we will not do this because there is no need. If we were in a room in which there is no gravity, then the objects would float freely throughout the space of the rooms, periodically colliding and chaotically rotating. Generally speaking, from a physical point of view, a room with objects without gravity will have a greater entropy value than the same room with gravity, since the number of possible object placements in the room space will be bigger than if the objects were lying on the floor. I do not specifically introduce scientific terms to make it clear for people far from science. That is, as you have already noticed, that entropy is related to the number of possible positions of objects in space. Moreover, if an object has a non-spherical form, then its direction in space also could be considered as one of the possible positions of the object. Since in modern physics assumes that the position of the object along each of the axes changes continuously, it is possible to imagine how big the number of possible positions of the object. If it simply moves along one line on the floor of the room, even without rotating. Indeed, the number is simply unimaginably large, but its absolute value does not matter for us. Much more often, we need to know what to do to reduce this huge number by 2 times, for instance. To do this, as you have guessed, you need to reduce the length of the room several times. In this case, the entropy of the room, in the presence of all the same things on the floor, will also be reduced, but not by a factor of 2, but by about 1.5. As you have already understood the direction you need to move, in order to reduce the entropy even more, you need to pack all things in one small box, in which they will be located tight enough, so as they will not to be able to change their positions arbitrarily. The same is applicable to things that are in the shelves. In general, when all the objects can be inscribed in a volume much smaller than the entire room, then the entropy of the room system as things will be less. This is called order at the household level. As we see, the order, from a scientific point of view, is correlating with the notion of order at the household level. I have already mentioned that entropy is directly related to the number of possible positions of an object in a certain room. And what if we have an object that is fixed relative to the room so that it cannot be moved in it? Here you can immediately start speculating that the object consists of atoms. And atoms fluctuate at any temperature above 0. Therefore, we will assume that our object is an atom, or even better, an electron. Can we go even smaller? I think it's not worth it yet. Imagine that we have an electron, which we somehow fixed. Stop. Where can we fix an electron? And how can we fix it? In fact, it is much more difficult to do than to say. Moreover, if a person implement a method of fixing of electron in place, then he can get a doctorate. I know that physicists will now start to object that the electron does not stand still, that they say it constantly flutter, even if it is cooled down to absolute 0. Still, suppose that we managed somehow to immobilize an electron and fix it in one position, relatively to what? Here one is waiting for another problem, that we cannot set the absolute position of the electron in space, we can arrange it in some way relative to other objects. If we are far from all matter, then we do not need to fix the electron. So, in such a situation, when the electron is far from the rest of matter, its position with respect to the rest can be considered constant, and any displacement of this electron in space will not lead to a change in its entropy, and it will be minimal. That is equal to zero. What does it mean? And this means that an electron can occupy exactly one state, and it cannot be less, since if you remove this electron, then there is nothing to talk about. And what if we have two places, or more, in which an electron can be located? Then the total entropy of the system can be larger. If we consider the possible number of permutations of an electron over all its possible positions, then the number of bits necessary for encoding the number of permutations will be directly proportional to the entropy of the system. Yes, exactly, it's the number of bits required to describe the state of the system. Doesn't it remind you something? So, we came to another interesting concept, namely, the realization that entropy is directly related to information necessary to describe the possible number of the system states. Conditionally speaking, the less a bit is needed to describe the state of things in a certain system, the less entropy it has. Now we understand why mom forces her child to clean its room. Just the number of bits required to describe the mess in the room does not fit into mom's head. Well, perhaps it's all for now. Good luck to everyone.